This is Algebra with Trig, section 3.2. We're going to solve our system of equations using the method of substitution. Using this method, we need to solve one of the variables for one of the equations for one of its variables. So we'll take the first equation because its leading coefficient is a 1. So since the x has a 1 for a coefficient, let's get that by itself by subtracting the 2y to the other side. That's step number 1. Step number 2 is to substitute that expression into the other equation. So we're going to take the negative 2y minus 2 and plug it into the second equation. And now we're going to solve for y. We have one equation with one unknown. Originally we started with two equations with two unknowns. So my y-intercept, or where it's going to cross the vertical side of y, is at negative 6. Now for step number 3, we substitute that value back into one of the original equations. You can also plug it into the revised that we did from step 1. So our solution is going to be 10, negative 6. You can plug that back into your equation to check it algebraically. Plug in a 10, plug in your negative 6. Negative 12 and 10 is negative 2, which is what you started with. Plug in a 10 and a negative 6. 30 minus 24 would be 6. Another method you can use is called elimination. That's when we get rid of one of the variables completely. You can multiply one or both of the equations by a constant value. When we look at these two equations, we're going to notice that the 2 can become a 4. It can do that a lot easier then we can make a 5 become a 2 or a 2 become a 5. If we multiply this equation by negative 2, then that first equation is going to become negative 4x minus 10y equals negative 28. The second equation is already 4x plus 2y equals negative 4. When we look at our equations now, the x's cross out completely because one of them's at negative 4 and the other one's a positive 4. We add our y's together and we divide by our negative 8. So our y value becomes 4. Now we're going to take that and plug it back into either one of the original equations. So I'll plug it into the first equation. multiply out 5 times 4, subtract over subtract the 20 across to get -6, and x is going to become -3. So our solution for this system of equations is -3, 4. Now we've talked about how to solve a system using substitution. We've talked about how to use elimination. In a previous lesson we've talked about how to solve a system by graphing. So we've had multiple methods on solving for x and y for a system of equations. A system is having 2 or more equations. You typically need, for the number of variables, you need that many equations. 2 variables, 2 equations. On this next page, we have 2 equations again. They're asking us to solve it by the elimination method. If you notice, it's not easy to make a 3 become a 5 or 3 become a 4. We're going to turn both equations into a new number, both coefficients. So I'm going to multiply by a 5. In the bottom equation, I'm going to multiply by a 3. It's completely your choice if you want to try to eliminate the x's or if you want to try to eliminate the y's. When possible, I typically get rid of x's just because they come first. Five times -37 is -185. Our second equation, 3 times -5 is -15. The x's cross out completely. When you divide by 11, 11 goes into 14 one time, with 3 left over. It goes into 33 3 times. Then plug it into either equation. We plugged in our 13 for the y. 3 times 13 is 39. Subtract over your 39. Divide by your 5. So our solution is 5, 13. These two equations make lines. The two graphs cross at 5, 13. We're going to solve this system of equations. You can decide if you want to get rid of the x's or if you want to get rid of the y's. Your choice. Let's get rid of the y's this time. So I multiply by whatever is going to turn that into the opposite of this coefficient. So it turns it into a positive 6y. This equation has a negative 6y, and we know that they're going to cross out. Now we also notice that the x's in this case are going to also cross out. Here's a situation where both of the variables cross out. we're going to get a false statement. 0 does not equal negative 2. We get no real solution. Similarly, if we try to cross out the x's, 2 doesn't become a 5 very easily. We could multiply by 2.5, but that can get kind of weird sometimes. So we'll multiply by 5 to both of these. Multiply by 2 to all of these. 5 times 2 is 10x. 5 times negative 6 is negative 30. 5 times 12 is 60. For the second equation, 2 times negative 5 is negative 10x. There our x's are going to cross out. 2 times 15 is positive 30. That's interesting. And on this side we're going to get negative 60. So our x's are going to cross out. The y's are going to cross out. And also the 60s are going to cross out. So what we have left is 0 equals 0. We have all real solutions, or you could say infinitely many solutions. So in this case, you have two equations that are the exact same line. So any equation that works in the first, or any solution that works in the first equation is also going to work in the second equation. In this situation, we have two equations. The lines never cross. There is no value that equals them both, so they're parallel lines in example 4, 4a. Here's a problem solving. We're going to have adult tickets for a matinee that costs $1 more than the children tickets. When 350 adult tickets and 200 children tickets are sold, the total revenue was $2,550. So we're supposed to find the cost of an adult ticket. So X is going to be the cost of an adult ticket. Y is going to be the cost of a children's ticket. So now we need to write our equations. Later on we're going to call these constraints. What are the constraints on X and Y? We know that 350 tickets at some price plus 200 children tickets at some price was supposedly going to equal $2,550. We also know that the adult tickets was $1 extra. So to make the X and Y equal each other, we have to add the extra $1 to the children's ticket. This is a common mistake. A lot of people will put the $1 onto the adults because the adult was more expensive. But remember, you're trying to make them equal. So the adult equals the child's ticket plus an extra $1. So now we have our two equations, two unknowns. This is not a system of inequalities. We don't have to worry about X is greater than 0 and Y is greater than 0. We just deal with our two equations like the systems we've been working with above. So I'm going to solve this by substitution. So we have 350 times y plus 1 plus 200y equals 2,550. Distribute. Collect our like terms. We can subtract over the 350. And when we divide, uh, 500 goes into 2,000 4 times, and the 50 goes into 200 4 times. So we know our Y value, the cost of the children tickets, are going to be $4. When we add $1 to figure out the adult, the cost of an adult ticket is $5. The solution is going to be 5, 4. We got the 5 by plugging the 4 back into one of our original equations.